Hi, good morning mga kasensya. Welcome to Maclean's TV. Today we will answer the questions which falls faster, a heavy object or a lighter one. So let's talk about basic science. In high school or even in elementary, a lot of our classmates ask to our teachers, Sir, which falls faster, a heavy object or a light object when placed at the same height? Now, the answer is very simple. Take note that if you can still remember that the acceleration due to gravity is 9.8 meters per second squared, or for convenience terms of computation we'll use 10 meters per second squared. And take note, acceleration due to gravity varies depending on your location on the surface of the earth. If you are the polar regions, since it's flattened and those places are closer, a little bit higher acceleration due to gravity, that is exactly 9.83 meters per second squared. And if you are located at the equatorial region, you have 9.78 meters per second squared. Now, going back to the question, basic question, which falls faster between two objects, a heavier one or lighter one when placed at the same height? Now, for example, this metallic lure, jigging lure, compared to this sabiki cloth. When placed at the same height, of course, logic says this one will falls faster and reach the ground at the okay, with the presence of air resistance. Now I will not try that because it will damage my lure. Okay, so logic says if you're going to release these two at the same height and release at the same time, this one falls faster and reach the ground first. But according to acceleration due to gravity, all objects, regardless of mass, regardless of shape, regardless of weight, in the absence of air resistance or neglecting air resistance, these two objects, when released at the same height and released at the same time, will fall to the ground at the same time. Why? If you can still remember, acceleration due to gravity has a value of, let's just use 10 meters per second squared. Meaning, every second, this piece of cloth and this metallic lure will gain a speed of 10 meters per second. So, when placed at the same height, of course, their initial speed or velocity is zero. If you release these two after 1 second, based on acceleration due to gravity, these two achieve a velocity of 10 meters per second. After 2 seconds, you have to add another 10 meters per second. So after 2 seconds, the speed of this cloth and the speed of this metallic lure is already 20 meters per second. After 3 seconds, you have to add another 10 meters per second. So after 3 seconds, the speed of this cloth and this lure is 30 meters per second until they reach the ground. So regardless of weight or mass, neglecting air resistance, objects when placed at the same height, when released at the same time, will fall and reach the ground at the same time. Okay, so let me show you the simple illustration and computation of a free fall, because we're talking about free fall. When objects are allowed to fall under the influence of gravity only and you're not giving them an initial velocity, those objects are undergoing the so-called free fall state. So if objects fall freely, how fast? That's the question. How fast? No? How fast? You have to use this very simple equation, V equals gt. Okay, so V stands for velocity, instantaneous velocity, while G stands for acceleration due to gravity, and T stands for time. And take note, G has a value of, for convenience, we will use 10 meters per second squared. Okay, now after 1 second, for example, you have time 1 second. Both the lure and the piece of cloth will achieve an instantaneous velocity of, let us substitute the value of g. You have 10 meters per second squared, and the value of time you have 1 second. So cancel second here, then you have 10 times 1, you have 10 carry meter per second. So both the piece of cloth and the metallic lure after 1 second will achieve a velocity of 10 meters per second. Since the change in speed for a freely falling object is always 10 meters per second per second. Now what about after 2 seconds? After 2 seconds, please allow me to erase my writing first. After 2 seconds time, you have 2 seconds, that piece of cloth, sabiki cloth, and that metallic lure, okay, substitute again to the given simple equation, g times t. Standard value of acceleration due to gravity is 10 meters per second squared. Okay, you have the time 2 seconds, substitute 2 seconds, then cancel 10 meters per second times second. So you can cancel 1 second here. Second squared means second times second. So second over second is cancelled. So you have 10 times 2, 20 meters per second. That cloth lure and that metallic lure, when placed at the same height and released at the same time after 1 second, has an instantaneous speed of 10 meters per second. After 2 seconds, they both have this instantaneous speed of 20 meters per second. So for example, they reach the ground after 5 seconds. So 5 seconds, if you're going to substitute again the value of time, 5 seconds here, so you have 10 times 5, then you have 50 meters per second. That is the final velocity of, for example, both the sabiki cloth and the metallic lure. So it's very clear that regardless of the mass, the size, or the weight of any object when placed at the same height near the Earth's surface and released at the same time, neglecting air resistance, will just fall to the ground or reach the ground at the same time. That is a simple physics. Okay? Because a lot of us, yes, based on experience, it's really very true that heavier objects, example, a stone and a piece of paper, when placed at the same height and released at the same time, stone will fall faster and reach the ground first. That is because of the presence of air resistance. But in the absence of air resistance, no, they will fall and reach the ground at the same time, because all those things undergoes the same acceleration at the value of 10 meters per second squared. Okay, so see you next time to my next video. Let's talk about plate tectonics. That would be all for today. Thank you for watching, and please don't forget to subscribe and share.